So as you probably noticed, for the past few weeks, we've been having some technical difficulties. I apologize about them. I know that some of you were joining me online or my past few sessions and you were trying to just ask some questions, but for some reason the audio is not working in the rooms. All the volume is all the way up, so I'm not sure what's going on there. But it seems like my audio from my end, it's okay. You guys can hear me. So I'm not sure. I'm gonna talk with my supervisors to try and fix that. Maybe the IT department has to come and help us around. But either way, today we had an even worse complication because we weren't able to use the projector at all or Zoom at all. So that's why I'm doing this little brief video. Plus, we made a lot of announcements today, so might as well just make a short video just updating every one of you. Um, I know that I have some of Dr. Roche's and Dr. West's students, mostly Dr. West since I'm working with him. But the exam is approaching next week. And today, this is when we finish the handout for chapter 9. So that means that they are going to be around 3 to 4 sessions before the final. Sorry, before the exam. Don't get scared. Before the first exam. Which should be more than enough time for me to help you guys review the entire chapter. Plus, on Friday, we should move on to the very beginning of chapter 11, since Dr. West, he told me that he might be including that. If you want to get ahead of the game, it's just basically reviewing acidity, ARIA, pK, trends, some additional reactions such as oxymercuration, demercuration, hydroboration, oxidation, and acid catalyzed hydration, those guys. And also something that should be relatively simple, which is IUPAC for alcohols. So yeah, that's all that should be included on the exam. But again, this is up to Dr. West. He's probably going to give you more information once we get a little bit closer to Friday of next week, because that's when you guys have the exam for Dr. Roche. I'm not quite sure when the exam is scheduled for, but you guys are probably going to be tested on more chapters than Dr. West. So yeah, just keep in mind that. But other than that, I feel like that was all of the announcements that we made. I was honest with you guys. Usually the first exam tends to be the one with the lowest average, because that tends to be the hardest one. But don't worry, like progressively as we move on through the chapters, it's gonna get easier and easier. So I wouldn't worry too much about it right now. Okay. Now, saying that, if you were in lecture today on Wednesday, you probably saw that your professor was doing some practice runs at the beginning of lecture in where he was asking for you to figure out the molecule based on HNMR, CNMR, and IR spectrums. So that style of questions, you should get used to that. Now, as you probably noticed, that can take a little bit of time. So that explains why the average tends to be low for the first exam, because probably 80 to 90%, or maybe all of the exam is going to be in chapter 9 with questions similar to that. So what tends to happen is that some students do not get enough time to finish the entire exam. But again, I always try to bring up the good side of it. Let's say, one, you're getting used to his testing style, so you're ready for the final. And two, there's still a lot of points left over in the semester. So again, don't get too stressed out. You're getting used to his wording style for questions. So yeah. Okay. Other than that, after all of the announcements there and the technical problems, we finally were able to continue with the handout. So once we were able to continue with the handout, the last topic basically is just two-dimensional NMR techniques. Now, probably you heard about these guys during lecture, COSI, depth, and head core. Now, are you going to be presented with the spectrums of those guys? No, absolutely not. You might see them later on if you take any upper division chemistry classes. I'm not quite sure. But the only one that you're going to see and that you're probably going to encounter at least at the beginning of lab, if you're taking orgo lab, is going to be depth. Okay. That one, it's very similar to CNMR, but as you can see, it stands for something a little bit longer, distortionless enhancement by polarization transfer. Now, the main goal with this guy is that it helps you tell you if you have like, hey, do I have a methyl group, CH3 group, a methylene group, CH2, or a CH group, okay? So CNMR, you have to figure out what kind of carbon connections you have. But for that, that's provided for you. Okay. So yeah, I feel like that would be only one question. Like anything on 2D NMR techniques is probably just gonna be one question in your exam. And it's just gonna be the definition of it. Sorry. It's gonna be what it stands for, which is all of this. Okay. He might ask for example, which two-dimensional NMR technique is able to differentiate CH3 versus CH2 compounds. That's your answer. Simple as that. Now, after that, we're practically just closing that our NMR discussion, and we're moving on to the very, very last concept, which is mass spec, which should be a review from Orgo 1. Now, mass spec, as we were talking about, that can help us figure out the molecular formula, but the special thing is that it fragments the molecule. Now, if it fragments the molecule, you're going to get multiple portions of the molecule, of course, but the two main types are going to be a carbocation, that's your positive charge, or a radical, that's the one with a little dot. Okay. Now, you have to be able to identify four major peaks, which are your base peak, M plus peak or parent peak, M plus 1, and M plus 2. Okay. Now, there's a table down below that is going to specify everything more clearly, but before we go through that, something conceptual that you should know about mass spec is that, for example, if you have an odd number as your M plus peak, that means that you have an odd number of nitrogen. Okay, so odd number of M plus or parent peak means that nitrogen is present in an odd number. Now, we were talking about this in SI. What happens if I have an even number as my M plus? So that can mean two different things. That can mean that you have an even number of nitrogens or no nitrogens at all. So that's why, as you can see here, I only talk about what happens with the odd number, not with the even number, because there can be two what ifs. Okay, so the only determined for sure it's the odd number. Okay. Now going back to this table is basically a pretty good summary of everything that you have to know for mass spec. Okay, conceptually wise. So as we were talking about your base peak, that guy is going to be the tallest one. And actually, let me start drawing out a little diagram right now that I actually did on the whiteboard today, but since the recording wasn't working, let's do this. Okay, so the one with the highest intensity, that's going to be like about 100% abundance. Of course, that's going to be your base peak. That's the tallest one overall. Now, next peak that you're going to find is going to be your M plus peak, molecular ion peak, or also it's called your parent peak. Okay, it has a few names. Now, your parent peak is going to be to the right of the spectrum. Okay, this guy is your M plus peak. Then, as you can probably guess by the next two peaks, M plus 1 is going to be 1 unit to the right of the M plus peak. So about here, M plus 1. And then very last one. Okay, I know that the drawing is not very proportional, but it should just be 1 unit down. Let me see if I can move this a little. Okay, so it looks somewhat closer to the actual placement. So yeah, this guy is M plus 2, and it's 2 units to the right of the M plus peak. Okay, so that's basically your basic diagram. Sometimes you're going to see that the base peak and the M plus peak are the same one. I've just seen one example particularly that your professor likes to show during lectures. So I would just wait for him to show it to you and explain it to you. But on the exam, usually he's pretty fair. So you're not going to see a problem in where two peaks are the same thing. Okay, so it's going to be pretty separate from each other. Now, let's get back to our table. So basic, as we said, we can always find it as the tallest one overall, but you also need to know what they represent. So base peak is just tells you the most stable fragment. Now, remember that before we were talking about fragments. So there are two types, carbocations and radicals. Technically, the most stable fragment is going to be related to the carbocation, okay, not the radical. Now, hopefully you remember this, but for a carbocation or a radical to be more stable, the more substitution you have, the more stable it is. Okay, so that means that tertiary carbocation is going to be more stable than a secondary than a primary. Okay. So yeah, that was pretty much it for your base peak. Now your N plus peak, again, that guy has a few names. It has molecular ion peak or parent peak. They all mean the same exact thing. And it's always going to be the one that's the tallest to the right of the spectrum. Okay, that's why the one in blue here, that's your N plus peak. Now, very important, this guy, it gives you a really good clue of the molecule. Why? Because it represents the total mass, the total molecular weight of the molecule. Okay? Now, N plus 1, that guy, we know where to find it, to the right of N plus. Okay. Now, this one's very important. That's why they're highlighted here. It represents isotopes of carbon, hydrogen, and nitrogen. Okay. Usually it's a very small peak. It doesn't really tell you that much information about how the molecule looks like on its own, but your professor loves to ask a conceptual question about this. He loves to ask what's the major contributor, in which case you should know that it's carbon-13. Okay, that's why it's highlighted. So keep that in mind. If there are any Rocha students right now watching this recording, I wouldn't worry too much about mass spec. Usually he doesn't cover that in lecture, but of course, if he does, like, you're more than welcome to watch this or just for funsies. But continuing on, M plus 2 peak, that guy to the right of M plus 1. Okay. Now that guy represents a few different atoms. It represents the it tells you that there's either oxygen, sulfur, chlorine, or bromine present in the molecule. If you don't have an N plus 2 peak, that means that none of the atoms that you've seen here are present in the molecule. Okay, now we were talking about different ratios. Now, the least important ones are going to be oxygen and sulfur. Okay, because the presence of them in the spectrum is going to be such a tiny peak that it's going to be hard to see, especially oxygen. But the major ones are going to be the highlighted ones, chlorine and bromine. Now, same conceptual question as before. What's the major contributor? That can be an exam question. And as we can probably notice, it's going to be bromine. Okay, that's the one with the highest percentage. Now, we can use those percentage. Those are very exact, but we can also use ratios, okay, because that's what they represent at the end. So chlorine is going to be a 1:3 ratio, and bromine is 1:1. Now, how do we use those ratios? Like, what do they mean? So for that, those ratios are always comparing your base peak with your N plus 2 peak. Okay. So if you're, sorry, it's going to be your N plus peak with your N plus 2 peak. Okay. So if the ratio is 1:1, that means that both peaks are going to be about the same height. Okay, so that means that bromine is present. But if we see that our base peak versus our N plus 2 peak, if we see that the N plus 2 peak is about like a third of your N plus peak, that means that chlorine is present. And as you can probably guess, oxygen and sulfur, they have such a low percentage that it's going to be really hard to find out which one exactly is present. But usually you're not going to questions on that. You're either going to have to apply them to read a spectrum, or like I told you, the conceptual question about what's the major contributor. But yeah, that was it. That's practically summarizing all those mass spec, at least what you have to know for this class. Okay. So then we just had two different problems. Now, before we talked about those, I told you that there's basically two ways in which to approach mass spec questions. One of them is just by basically knowing this table, by knowing the concepts really well and how to apply them. Or you can also rely on math. Remember that on your exam calculators, I feel they're gonna ask you for calculators, so you have to bring your own. So yeah, that can help you in this portion, but also remember, you have to use your calculators for the chemical shift equation, which is most likely just gonna be one question. But either way, let's go to the problems in here. So in this case, it says, what does the presence of an 18 mass per charge N plus peak most likely correlate to? Okay. So M plus peak. As we learned before, this guy gives you the total mass of the compound. So in this case, I'm going to combine both my conceptual knowledge and my math knowledge. So you're going to start finding out the weight of each of the answer choices provided. We have 15, 16, 17, and 33. Okay, remember, we're getting those numbers because by adding up the atomic weight that we find in the periodic table. Okay, now we were given an 18M plus peak. So basically, you just have to mix and match. Which one is closer to 18? The only one is going to be your alcohol, that's 17. That's like 1 unit off. But yeah, that's going to be a type of questions you might get. Or you might get something like on the second one. What is the molecular formula for a compound with an M plus peak at 1, with a minor M plus 1 peak? Okay. So I would just start by highlighting the information that is provided for you. So one of them is just the M plus peak. M plus peak, again, very important. It gives you a pretty good clue. It's the total mass of the compound. But also, I see that 101 is an odd number. If I have an odd number as my M plus peak, that means that nitrogen is present, and specifically, I have an odd number of nitrogens. Okay. So just by knowing that, I can automatically start discarding some answer choices. 1, A, there's no nitrogens at all, so we discard it. B, it has nitrogens, but it has 2. That's an even number, so we discard it. C, it has nitrogen present and it's an odd number. And then D, we don't have any nitrogen. So just by knowing your concepts, you should be able to figure it out. But in case if you just, I don't know, if you start to panic, all of the concepts are, you can't remember them, do the math. See which one approximates the most to 101 as far as the molecular weight. Because remember, that's what the M plus peak represents. Now, the next piece of information that we were given was your M plus 1 peak. But as we can see in here, it didn't really tell us that much. It just that there were isotopes of carbon, hydrogen, and nitrogen. Okay. Now, but another clue that we could have used is that we don't see any M plus 2 peaks, which means that if there's no M plus 2, there's no oxygen, sulfur, chlorine, or bromine. So that's when we can also start discarding option A and option D because they have chlorine and oxygen. Okay. So that was the end of the handout. I just wanted to do this quick video in case you weren't able to write down the notes as fast as we were going through them on the board, or in case you couldn't come and you wanted to watch the recording. So here it is. But if you have any questions, just let me know. We're going to be moving on to chapter 11 on Friday. So yeah, that was it.